My name is Dr. Chris Jenkins, and I am the CEO of the Orianne Society and the host of the Snake Talk podcast, the podcast where you learn about nature's most feared, maligned, and persecuted animals. I invite you to listen to this conversation, and maybe you'll find that what you perceive as fear is actually rooted in a deep fascination. Welcome to the Snake Talk podcast. We have a good one today. I am here with Dr. Michael Caldwell from the University of Alberta, where he is a full professor. And we won't get into the details yet, but him and his colleagues recently made a fascinating discovery that we're going to talk about. But we're going to really kind of focus today's conversation around snakes, and in particular the evolution of snakes, the origin of snakes and squamates. And this is it's really a fascinating topic for me, as many of you know. I really enjoy episodes that are kind of outside of the box for me. And, you know, being a conservation biologist and an ecologist, I mean, I had some classes in evolution and I had herpetology classes, but this is definitely an area that I know relatively little about within the snake world. So I'm excited to learn right along with all of you today. So welcome to the podcast, Michael. How are you doing today?
I'm doing well, Chris. Thanks very much.
Yeah, so I like to kick off all of our episodes by figuring out how our guests got to where they are today. And I typically start at the very beginning because usually a lot of the things that we are interested in are thought of as rather kind of eccentric for a lot of society. And so, I like to learn, in your case, whether it's snakes or fossils or evolution, like when did that interest hit you? Is that something, you've always had in you since a child? Is that something that kind of developed over time as you built your career? Where'd that come from?
Where'd that come from? Wow, that's an extremely good question. My snake eccentricity, as you put it, is kind of a late stage development in my life. Like a lot of little kids, I started out as a child being fascinated by fossils, and just about anything paleontology was fascinating to me. And of course, that extended to the natural world around me as well. I loved frogs and critters and plants and hiking and being outside and rocks. Northern Alberta, where I grew up, we've got lots of garter snakes, but that's pretty much it when it comes to the snake side of Alberta herpetology. If I go a little bit further south towards the Montana border, I can pick up a few bull snakes, rattlesnakes, and a couple of hognose snakes. But snakes aren't exactly common around here, so they weren't part of my kind of childhood, natural history zoo in the place I grew up, Chris. But the rocks and fossils were, and that one stayed with me all the way through childhood and into that early stage of being a young man, when my mother and father cleverly pointed out to me that, to the best of their knowledge, paleontologists didn't make very much money, so I should go to law school, which shockingly was the first thing I actually tried to do, and I discovered it wasn't my cup of tea. And a couple of undergraduate degrees later, I finally had finished my undergrad work in paleontology, and I still wasn't turned on to the snake thing, like a lot of wannabe paleontologists as an undergraduate student. I thought the world of paleo was all about dinosaurs. And I left Alberta at that point. That was the summer of 1991. And I headed off to McGill, where I did my PhD with Robert Carroll, who had been a student of Al Romer's at Harvard. In fact, he was Al Romer's last student. And these are sort of famous names in the canon of vertebrate paleontology here in North America, to say the least. And Bob took one look at my interest in what I thought would make for a great PhD project, had himself a laugh, and put me on this evolution and ontogeny problem on secondary aquatic adaptations in reptiles. And snakes still weren't part of this, Chris. But this got me into mosasaurs because I was looking at whatever the fossil record had to say about the evolution of paddle-like structures or swimming appendages in secondarily aquatic marine reptiles from the last couple of 100 million years of vertebrate evolution. And that got me into mosasaurs, and that got me into this obscure group of critters called the dolichosaurs. And they're a kind of, basal relative sister group to this mosasaur lineage that everybody knows about quite well. And the dolichosaurs took me to Israel, of all things, in the spring of 1996, along with one of my postdoc pals, a guy by the name of Mike Lee. Mike was in Australia. He had some Australian Research Council grant cash as a postdoctoral fellow. I had a Canadian postdoc fund, but didn't give me any research cash, just a salary. Mike said, "I've got money. Let's go see these dolichosaurs in Israel together." So off to Jerusalem we went. And this is my snake moment, Chris. This is where the whole thing happens.
Okay.
This is where the big turn occurs. I was already kind of headed towards lizard land, that squamate side of things because of mosasaurs and my interest in the dolichosaur stuff. But I had no idea really what was about to happen when my pal Mike and I got to the collections at Hebrew University in Jerusalem, opened the drawers that first morning, and realized, well, damn it all to hell, that is not a dolichosaur laying in the drawer in front of me. And in fact, it was a snake, a 100 million year old snake. We've got 3 specimens of this thing, and they were beautifully articulated, preserved in quiet lagoonal limestones. And this is the beast that made Nature in 1997, Caldwell and Lee, Pachyrhacus problematicus, the first described Cenomanian Mesozoic age snake with rear limbs, with back legs.
Wait, so the museum staff didn't realize that those were snakes? Oh, okay.
No. The fellow who had given names to these things a decade and a half earlier had recognized some snake-like features in them, but decided that snakes, and this will definitely be part of our conversation today, he had decided that because he was a herpetologist and spent a lot of time with scolopophidians, and scolopophidians were the accepted basal-most or most primitive snake archetype out there, that because these things weren't scolopophidians, they couldn't be snakes because they were 100 million years old, and this would tell an entirely different story than the one that he was familiar with and the one that he held as kind of the center of his worldview on snake phylogeny and snake evolution. And so, in fact, they'd been drawered for 17 years from the time of their first description, and nobody recognized them as snakes, even though people chatted about a few of their snake-like features. And Mike and I, on the other hand, decided, there you are, brash young postdocs. You've got your young Turk syndrome still on the go. This is a great Nature paper, and this will be our first splash and foray into the world of snake systematics. And my career has been stuck on snake evolution and snake paleontology ever since. That's how I got here, Chris. It's
a great story.
Yeah.
Let's go back just for the audience. You mentioned mosasaurs, so just describe those in general. I think most people probably know what they are or have seen an image of them, but just describe what a general mosasaur might look like.
Yeah, well, if we go to the top of the mosasaur tree of evolution, we're talking about big-bodied. Big-bodied is an understatement. They were gigantic. Some of the largest ones we know of were around 50 to 55 feet long,
Wow.
snout to tip of tail. Now, these are the extremely large ones. The bulk of them are not. But they were big-bodied marine lizards that developed flippers, caudal fins, probably in possession of dorsal flukes on those caudal fins, and the caudal fin was downturned, like you would imagine in an ichthyosaur, for instance, which people are much more familiar with. Mosasaurs had a short neck but a big head, and occupied, I can only imagine, kind of that apex predator niche in their feeding systems or trophic systems in the Mesozoic oceans of the world, beginning at about 90-ish, 92-ish million years ago, right through to the KP extinction event. That's when the fossil record at least suggests they completely disappeared. So for about 30, 35 million years, this very diverse group of lizards, there are around 40 described genera and 70 some odd species, which means, of course, that's the tip of the iceberg of diversity for mosasaurs. And there were probably thousands of species, like you would expect in a radiation of very successful lizards. Look at skinks or geckotins today, 12, 13, 1,400 species of these things. We would have expected the same sort of thing from that radiation as well. They were globally distributed in all the world's oceans. We find them in, the Antarctic today, as well as up in the Canadian high Arctic and the Russian Arctic. There's good fossil records of them. Not great specimens, but it was clear they were there. And then everywhere else around the planet. Small-bodied, large-bodied. Some had, most of them had very characteristic anatomies to their paddle-like limbs, very characteristic skulls for the groups that they belong to, and some of them, in fact, retain what you would think of as the amphibious terrestrial limb, well into the evolution of the group. So a lot of diversity. Yeah. In the same way that modern groups of lizards like the anguids have limbless forms, or the skinks, even better, have limbless forms, and then every version of limb loss in between, as well as fully limbed forms. That's the kind of thing we see in that radiation of mosasaurs as well. There was a lot going on.
Yeah.
But the ones that people are familiar with are that big-bodied, sea-going, flipper-bearing, caudal fin-bearing critter.
Yeah, thank you. I just want to put that kind of picture in people's heads for, as we get talking about evolution of snakes here. So you go to Israel with your colleague and you make this really significant discovery. And maybe to kind of kick off the, since it was kind of the launching point for you in this part of your career, when you went in and made that discovery, maybe talk a little bit, it can be in kind of a general sense, but what was thought to be kind of the general pattern of the evolution of snakes, the origin of snakes, and how this discovery that you guys made, any changes or new trajectories that it may have put that, that line of thought on.
Have we got 3 hours for this conversation, or is this a 5-minute answer? Yeah, that one opens up a kettle of fish the size of next week, Chris.
That's the point. That's the point.
Things to me yeah. One of the fascinating things for me as my career has developed is to spend a long time wading in the deep end of that swimming pool of what science is and how we do science. And in the process of becoming exposed to that and thinking broadly, and I like to think of it as deeply. Maybe other people think I've never had a deep thought in my life. Who knows? But in thinking deeply about that particular sort of thing that we do and how we do it, in other words, the philosophy of science, and contextualizing that around the specifics of what I do in science as a squamate and, more specifically a snake evolutionary biologist, paleontologist, systematist, whatever you want to call it. and then thinking back to your question about what was the effect and what did I learn about what it was and how it is that we have for so long thought about what we thought we knew, in other words, those epistemological and ontological issues around the origins and interrelationships of snakes. This is what really my career has been about, man. And if I think back to 1997 and what I didn't know about what I was about to wade into the middle of, as opposed to what I do know about it now, I'm grateful for the fact that I was naive and willing to hop into that mess, because it has defined my career and it has defined me. There's controversy out there about snake origins, Chris, and if I take the me now and what I know and the way I view science, what I've come to understand is that in 1997, if we use George Haas and his early description of Pachyrhacus problematicus and his decision that that blind burrowing scolophidian snakes are primitive, therefore this can't be a primitive snake. That should tell you right there that there was an origins hypothesis in his head as well as a phylogenetic hypothesis in his head. And if we go back to where the burrowing origins of snakes starts, this is in the 1930s, with in particular the work of Mahendra, and I think it's what's the publication? Oh, the Indian Journal of Science, I think, 1938.
Yeah. But the general thought there that you're talking about is that snakes evolved from lizards and they lost legs because they didn't need them, because they became more of a burrowing type animal.
Exactly. And what's fascinating to me is that this origins scenario, and it's very clearly presented in the literature in the late 1930s, and then reiterated again by some very formative work done on eyes and retinal histology, eye histology, in fact, by somebody who was really a vertebrate eye specialist, but had no particular interest in the evolution of snakes. But this is where this all gets started, and it's an origin scenario in the absence of a phylogeny of snakes and squamates generally, which in terms of the way that we practice the business now is the opposite way to go. We preach to undergraduates in biology classes and paleontology classes that you need a phylogeny first as a foundation on which to then build subsequent hypotheses, such as origin scenarios, the evolution of particular traits, because then, at least in the context of that foundation of phylogeny, you can view the progression, so to speak, between sister groups of a particular anatomical feature, or you can at least then go back to your closest relatives and come up with an origin scenario based on a hypothetical ancestor concept that would have been shared by those two groups at the root of that particular phylogenetic hypothesis. The burrowing snake origins story started the other way around. It started as a burrowing origins story. And even Garth Underwood and Angus Bellairs, a couple of British scientists who in the 50s in particular and into the 60s and 70s wrote a great deal on the origins of snakes. And they were pro-burrowing origins hypothesis or scenario. I'm not even sure it's really a hypothesis, but they were pro-burrowing origins. And even they admitted that all of this still hinged on one key problem, and that was the absence of a phylogenetic hypothesis nesting snakes somewhere within that lizard radiation. Mm-hmm. And this has kind of been, and ever since has been, the real research focus of my career as I've continued to work my way around the planet. I mean, I've literally seen, with the exclusion of the material in Russia because it's awkward to get to it, I've literally seen every other fossil snake from the Mesozoic on the planet. I've been everywhere. I've published on a large number of them, discovered a large number of them, and gone back and studied in detail everything that anybody has ever written about the early snake fossil record. And keying that into to my general approach to how do we ask questions about phylogeny, and subsequently how do we ask questions about origins, this has really been the focus of my career this last 30 years.
So, so I understand that you start with the phylogeny. Well, let me go back to Israel. So you make this discovery. What about these ancient snakes that you discovered in the museum there? Did you learn anything from those snakes that might point to maybe an alternative origin story for snakes?
Well, yes, and the alternative origin story. If you read the literature, lots of people have accused me of being a proponent of the aquatic origins hypothesis, and I'll tell you right now that's complete rubbish.
I did read a little bit about that. I was prepping for this, but go ahead.
Yeah. Lots of people say Caldwell and Lee are proponents of the aquatic origins hypothesis. That's absolutely just not true. What we found in terms of phylogenetic relationships, or a hypothesis of phylogeny. And let's be clear, no one's phylogeny is absolute truth. They're all relative truth statements. And that's why they're called hypotheses. But our phylogenetic hypothesis, as far as I'm concerned, the ground that broke in 1997 was that we placed Pachyrhachis outside of, what we'll call the crown of Serpentes. So in other words, Scolophagians and Alithanophidians were sister taxa above the level of Pachyrhachis. And what that really suggested to me was that Scolophagians aren't the basalmost or most primitive snakes, even within that crown radiation. Even though in that particular hypothesis, we didn't place them higher within Alithanophidia. They just came out as the sister taxon to Alithanophidian snakes. But finding Pachyrhachis to be below that position in the tree would immediately suggest that whatever anatomies of Scolophagians, in other words, that blind burrowing thing that seems to characterize all three members of the Scolophagia, paraphyletic or polyphyletic as they might be, those finding Pachyrhachis below that suggests that those features aren't primitive for Pan-Serpentes. Maybe they're basal for the crown, but that isn't the origins of snakes at all. If Pachyrhachis is a snake, then the suggestion would be that snakeness is an entirely different sort of question in terms of its origins below where we would reconstruct Scolophagians in that sister position to the Alithanophidian radiation.
And so the Pachyrhachis, am I pronouncing that correctly?
Yeah, Pachyrhachis.
Yeah. So, what did you learn, looking at the fossils? I mean, what could you learn about their ecology? I think you mentioned that they would have been encased in limestone. Unless I heard that wrong, were they aquatic or?
Snakes are one of the most persecuted groups of animals in the world, but we are dedicated to changing that. If you like what we've been discussing here on the Snake Talk podcast, here's an opportunity to turn that inspiration into action. Head over to www.orian.org and explore how you can support the Orian Society. Click on Take Action on our menu to make a difference.
Yeah, marine snakes living way the heck out on, think of the Great Barrier Reef system today, and then off the coast of Australia, and then multiply that by about 1,000 times. And this was the patch reef system that existed between what we think of now as North Africa and Southern Europe. There was tectonically a nice rift line still separating North Africa from Europe because the two are different plates. But coming across that big chunk of open ocean that existed at the time, the Tethys Sea, was one of the most spectacular reef systems, reef platforms that we have in that part of the Mesozoic. This thing was gigantic. Give or take a little bit, the Pachyrhachis material and a closely related suite from the same locality and then from Lebanon in slightly younger rocks. We have three different taxa. We have Pachyrhachis, Eupodophus, and Haseophus. And they're all rear limb or hind limb bearing snakes. No vestiges of the forelimbs, but they have very different skulls. It's a bit like comparing boa to, Coluber, and then, Natrix. You can pick them all out based on the anatomy of the skulls very easily. And
so probably very different diets and, evolved.
Different diets, different evolutionary histories, members of their own diverse lineages. Yeah. Quite different snakes. So there's a lot of snake evolution going on to produce these three very distinct cranial morphotypes. And as well, they all are still in possession, though the rear limbs aren't the same. They're all still in possession of small but still external rear limbs with toes. So limb loss has clearly been proceeding convergently as well, or independently, within these different radiations of coeval snakes. There's a lot happening that we just don't know anything about. And they're about 400 kilometers off the north coast of Africa at this point in time, way out in the middle of this lagoonal patch reef system. And the whole reef system was absolutely chock-a-block full of these giant weird clams called rudists. They look like ice cream cones with a cap. And they were the reef-forming organisms at the time. And they made giant reef systems that extended all the way across the Tethys Seaway to southern Europe. It's kind of a spectacular paleo environment. And at the same time, there are terrestrial snakes with rear limbs down in Argentina at this point in time, 100 million years ago. So snake evolution was alive and well and diverse. And what we came to understand, and what's been a theme in my research work ever since, is that big bodies and big mouths, not necessarily the boa-like macrostomate gape thing, but not the scolopophidian tiny head I can barely eat an ant larvae kind of mouth either. The bigger body, bigger mouthed animals, which is unsurprising considering they evolved from four-legged lizards of some kind or another, is the early body morph for early snakes. What the earliest snakes might have looked like that still had four legs, oh man, that's a search image I'm still working on, Chris, when it comes to hunting the fossil record. But yeah.
So you don't feel you don't feel sure that that necessarily occurred in an aquatic environment or a terrestrial environment.
No, absolutely not.
Subterranean.
No. Yeah. No, in fact, one of the really fascinating things, again, that's been percolating in the back of my head for this last couple of decades, is just how many times through the evolutionary history of snakes, probably once they evolved whatever it is that essential snakeness, how many times they've invaded aquatic environments. I mean, we know modern elapids did it, 5, 6, 7, 8, 9, 10 million years ago and resulted in sea snakes and sea kraits today. We've got acrocordids that are in and out of marine environments. And, find me an extant colubroid that's afraid to go in the water. I haven't met one yet. They may not be marine, but they're certainly competent in aquatic environments. I used to have a pet garter snake, Spot, little red-sided garter snake from around here. And Spot's favorite meal was a bowl full of goldfish. And he didn't go hunting from the top of the bowl. He hopped in. So he had a big bowl.
Yeah.
Snakes are very competent in aquatic environments. And I look at the fossil record and I see multiple invasions in the fossil record of marine environments, which are easily identified in the rock record. General aquatic environments, everything except a desert is an aquatic environment when it comes to sedimentation.
Yep.
But marine environments, this is where we find the beautiful articulated things, or in the desert environments in Argentina as well. But snakes have been in and out of the ocean, as far as I can tell, for at least the last 110 million years. And they've done it repeatedly.
Mm-hmm.
In fact, I suspect right after the Cretaceous Paleogene extinction event, that the big giant things like Titanoboa and the other gigantophid matsoid radiations, that they were using aquatic environments, if not marine corridors, as means of radiating. They were using them as radiation corridors and radiation routes. They seem to be all around the world, and in the same environments where we find ancient whales.
Yeah,
snakes were everywhere.
Yeah. Well, so based on your work, as well as just kind of our general understanding, and if we talk about the origin of snakes, it sounds like we obviously don't understand exactly how that happened. But what's the time frame here? We've been throwing out 110 million years, and I mean, do we have a good general kind of window for when we think snakes first appeared on this earth?
Yeah, so this is gonna bring us to a question of just what is a snake, and I'm of the mind that being long and skinny is not what makes you a snake. For me, it's all about the head, and I use that not just as a means of probing the fossil record, but also that idea is derived from my observations of other groups of limb reduced to completely limbless living lizards, where if I take a legless anguid, and I can tell you it's an anguid not because of the incredibly elongate body. I think of Ophisaurus apotus as an example, but rather it's an anguid because of what it has for a head.
Mm-hmm.
The skull anatomy makes it an anguid. And you put 4 legs back on it and make it short, and it's still an anguid. Or you take all the legs off and make it long, and like an Anielid or Ophisaurus, you've got an anguid. It's still an anguid by skull. And the same thing holds true for the skinks. The genus Larista, Australia. I don't know 150 described species of Larista. Some of them have 4 perfect legs with 5 toes on each limb. And some of them have absolutely no limbs, and other ones got a femoral spike with 2 toes and a humeral spike with no toes at all, and then everything in between. But you can tell they all belong to the genus Larista because of the possession of their cranial anatomies. The skull is the decider. And the same thing is true for any of the extant groups. The only ones that give us a bit of a problem are dibamids, because there are no limbed forms. And for the most part, amphisbaenians, with the exception of bipes and its weird little digger forelimbs, otherwise, that principle holds true.
Mm-hmm.
The skull is what identifies a critter as a member of that particular group. It's not being long and legless. And so if I take this and I think about snakes and start pushing the fossil record that way, I don't go to the fossil record looking for limblessness in order to identify a snake in the rock record. I'm going to go looking for the skulls, because this should be the signal. This would be the ecomorph territory early on in snake evolution, where snakeness pops up. And the subsequent limblessness thing is going to be an innovation within the group, in the same way that it's an innovation within living groups of lizards that have limb-reduced or completely limbless forms. So the fossil record, Chris, which is where this long-winded circle is taking us back to. The fossil record, I can find perfectly fine examples of good snakes with snaky bodies, even though they still have those pesky rear limbs, taking us back about 100 million years or so, which means that the snake condition of the skull had to have evolved much earlier than that. I think of snakes as probably looking a lot like skinks, going back 150, 160, or 170 million years ago, where we would expect to find four-legged snakes with short bodies, but in possession of snake-like features of the head. And those would all be around feeding adaptations.
Yep.
Decidedly not that Scolopophidian morph, but rather a bigger-bodied, big-headed, big-mouthed, typical sort of lizard that could swallow big things. I mean,
like a varanid or something. Yeah,
exactly. They can swallow big stuff too, and that capacity and that cranial suite of innovations is where my search goes to. And at the moment, that takes us into the middle to early part of the Upper Jurassic or late Jurassic, which is pushing it at about 160 to 170 million years ago. And there is some, what I think, really conclusive evidence of snake cranial adaptations in a number of fossil forms that are broadly distributed, unsurprisingly, around the world. There are exemplars from here in North America, from the Morrison Formation in Colorado and Utah, from a coal mine, a Jurassic coal mine in Portugal, and then from the South English coast around Dorset. And there's some really lovely stuff that just has hit the scientific news, but not been published. It's been presented at a couple of conferences. It's controversial, which is to be expected, and exciting. And it's coming from the Middle Jurassic of the Isle of Skye up in Scotland. And I'll point this out for those who might be like myself, whiskey fans, within reaching distance of the Lagavulin distillery on Skye, which is wonderful. But in any case, that's where this goes. And this one lovely specimen that yet remains out of the literature but has been presented has four perfectly good legs and what appears to be rather a short body. But I'm seeing mobile pterygoids, mobile maxillae, all the cranial features that I would expect in something that's at the early stage of defining the group that's going to arise from it and its relatives around those sort of skull specializations, which is what we use to define groups like snakes.
And how old
skinks.
Is that fossil, approximately?
This is Middle Jurassic, so about 160, maybe 160, maybe 155 million years.
So maybe for the audience, obviously the Earth is a large place and very dynamic over these long time periods, but I just want to kind of paint an image for the audience of what the Earth might have been like at that time when snakes were evolving. I mean, again, obviously the Earth varies incredibly, but I mean, what were some of the major things happening on Earth when we think snakes evolved in terms of where the continents might have been, like general climate patterns, those types of things?
Yeah. Well, I'll contextualize it with a bit more of the lizard / squamate story, and I have a hard time separating lizards from using the word squamate as opposed to lizards. I mean, for me, snakes are a kind of lizard. Every time I read squamata is composed of snakes, lizards, and amphibians, I cringe because snakes are nested within lizards, as are amphibians, and Lacertilia and squamata from Mike Caldwell are kind of synonyms. But I'll run this back into the Triassic, so taking us back a couple of 100 million years, and this is this zone where we seem to have a really good late Triassic, maybe middle Triassic fossil record of sphenodontians, Sphenodon punctatus, the poor sad leftover tuatara. The diversity of that group was quite spectacular through through the middle to late part of the Triassic. And this is a point in time when the radiation of most of the major groups of neodiapsids, the lepidosaurs that will eventually include the squamates or the lizards, and the archosauromorphs that will include birds and dinosaurs and crocodiles and probably turtles, depending on where you're comfortable placing turtles as diapsid reptiles. All of that is happening through the Triassic. And I think, one of the reasons we have difficulty placing the time of origin, and I'm going to put air quotes around that, even though I know this is a podcast, for lizards and squamates, is because recognizing just exactly when those definitive features pop up in that rapidly evolving spectacle of lepidosaur evolution, where there are a bunch of things around at that time that aren't sphenodontians and they're not squamates. They're still kind of stem to it. They don't share all of the crown features we look for when we want to define sphenodontians and squamates. All of that is this. It's kind of a melting pot, Chris. It's a melting pot of anatomy, and the fossils are frustratingly far and few between, and they quite often show features that are almost chimeric. On these, on what we like to think of as these lovely endpoints that exist now, 200 million years down the road. And that's not surprising, but that causes us a problem, when we want to think of squamates as oranges and sphenodontians as apples, and suddenly we have an apple orange in the fossil record. It makes for a muddy story, and we have a hard time separating it because we've got such good data from the here and now that it often swamps, what we want to try and understand from the past when the here and now didn't exist. And looking at that Triassic fossil record, I can start to map, and it's not stepwise, it's chimeric, it's all the hell all over the place. It is a muddy mess. But I can start to map the acquisition and the canalization, if you want to think of it that way, of features that will eventually give us the here and now. But it's messy. And I would guess that if you could have sat there for about 40 or so million years and watched that soup moving in the direction that it would eventually move, that you would start to see the earliest version of a squamate. And I describe it this way at the peril of making it sound like some of these groups might have had polyphyletic origins. In other words, multiple origin events within that radiation. But sometimes when I look at things like amphisbaenians and I think they might have come from outer space, I'm content to think, in fact, that maybe it was multiple origins for what we like to think of as a lovely monophyletic assemblage, the modern lizards or squamata today. But somewhere in there, I can start to see early anglomorph characters by the time we get into the middle part of the Jurassic. Skinks or skinkomorph features are definitely in place. We have a giant grab bag fossil taxon called the Paramassalodidae, which boils down to ancient skinks that just don't quite look like anything today, but they're very skinky. And that includes chordilids as well. There's that whole soupy mess of this early part of the Jurassic. And somewhere in there, again, this is where the first snakes pop up, or that snakeness features, that suite of snakeness features begin to become canalized in the skulls of these early four-legged things.
Yes,
and I think that's...
I was just going to say that's just a pretty good job of kind of leading up to, the animals that led to them through this time period. But again, back to that original question, what was the Earth like? What do you think the Earth was like when snakes evolved?
Sure. Yeah, well, it's not like it was today. It's impossible to put a climate picture together. I mean, climate, as we know today, is incredibly dynamic, and it was incredibly dynamic in the past. It's easy to, put together a plate tectonic reconstruction and call it the Jurassic. But if you do that, you're talking about 55 million years of Earth history,
Yeah.
Which would be like trying to characterize the last 55 million years as having been uniform.
Yeah, good point.
When we know that it has definitely not been uniform. We've had an ice age or two to deal with, on and off over the last couple of million years. We're currently in a warming trend. We're not getting anywhere close to the Paleocene-Eocene thermal maximum at 58 million years ago, where it was freakishly hot around the entire planet. And taking us back into the Cretaceous, we've had ups and downs the same way, and the same thing into the Jurassic. There was a good glaciation at the end of the Permian and the beginning of the Triassic, big global one, and it warmed up prior to that. So after that, and as we move into that period of time, just in terms of climate patterns, where middle Jurassic, or probably, if you apply the principle, if you find something in the fossil record here, it clearly means it evolved before that. Uh-huh. If we apply that principle, if I've got good four-legged snakes in the middle Jurassic of Scotland, then I've probably got snake evolution occurring significantly before that. Uh-huh. But things are warm. And overall, at that point in time, they're warm. The continents, Laurasia was a reasonably good chunk of rock. In other words, parts of North America and Asia are forming a bit of a supercontinent in the northern hemisphere. Gondwana is still together in the south. And Gondwana is a really important one in later snake evolution, because whatever goes on in the middle Jurassic leads to a distribution of early snakes that later become isolated in Gondwana. And that one's a pretty important part of the Mesozoic, particularly into the Cretaceous and right through to the present story of snake evolution. But in that origins 10 million year period of time, globally, it's mostly warm.
Gotcha.
But the critters that we're finding in those rocks, both Scotland and southern England on that Dorset coast, these are it's an island archipelago up there. I'm not suggesting these are aquatic snakes. I don't think so. I think these early guys are probably little terrestrial critters running around in these terrestrial island environments. How they got there, I haven't got a clue. And likewise, the Morrison Formation stuff, this is western interior of the U.S. At the time. And all around where we find these little parvoraptorine early snakes, and again, some air quotes, a lot of people will argue that one. But that's a big, dry inland, sand sea dominating good parts of the middle of North America. And the Portuguese example, which is some of the best preserved material, though none of it's articulated, that's coming from a coal mine, which was a coal swamp, which places these critters in marginal marine environments and delta estuaries where you could get coal swamp development. So the fossil record of what could be some of the earliest snakes is coming again from a multitude of diverse environments, none of which are the same at all, which I think is incredibly exciting, because it means there's an unbelievable amount of evolutionary radiation and adaptation that's gone on to get these different early, snakes, proto-snakes, stem snakes, I don't care what you want to call them, into these different environments around the world at the time. Which means we got to look at even older rocks to see if we can get some sort of hint and or signal, even deeper on the origins questions. Yeah. Which again, all of this takes us completely away from that old 1930s model of the blind burrowing snake as the origin of snakes, primitive snake.
Yeah, I mean, that's one of my big takeaways from this whole conversation. Obviously, I've learned an incredible amount. But let's, we've been going on about 50 minutes and still have a little bit of time here, but I do want to transition. We could keep talking about this stuff. It's fascinating to me, and we could keep talking about it for hours. But for the sake of everybody's time, I would like to transition a little bit and talk about the recent discovery and the news that kind of prompted me to reach out to you, and this discovery that you and your colleagues made in Wyoming. And so I guess I'll just leave it there. And why don't you first of all tell us a little bit about that work and what you guys discovered and the significance, and then we can kind of take it from there.
Whether you're passionate about preserving biodiversity, ensuring the survival of threatened species, or simply want to contribute to a healthier planet, there's a role for you. Your support isn't just a contribution, it's an investment in a future where our ecosystems thrive. Go to www.orian.org to donate or become a member today.
Well, I'll give you, I'll give you an origin story on this one too, kind of like the Pachyrhacus one at the beginning of our conversation. Most fossils are not found by the paleontologists who described them. This one has the same sort of story. 1976, the specimens were collected, I think, by a field crew from the University of Wyoming in Laramie, and off to collections they went, like so many things do. I've done some of my best work opening museum drawers and going up and proceeding from there. Sort of you're not the pirate that stole it; you're the pirate that found the buried pirate treasure. It's that sort of an adventure. And 1985-86, the fellow that we named the species after. So the genus is Hibernophus, and I'll get to that in a minute. And the species is Breithaupt. It's named after Brent Breithaupt, who's been a key figure in the North American vertebrate paleontology scene all of my academic life, and a very good friend of mine, and collections manager at the University of Wyoming's collections in Laramie. Brent wrote a little paper with a colleague of his talking about, they'd gotten the specimen prepared, and they were talking about the assemblage, the social behavior sense arising from this particular specimen. Because what it is three beautifully articulated individuals. One's quite a bit bigger than the other two, all coiled up together in what appears to be a fossilized mammal burrow. So, several exceptional things here. Articulated snakes are as rare as hen's teeth in the fossil record of snakes, which is dominated by, probably millions of disarticulated snake vertebrae in museum collections around the world throughout the fossil record of snakes. So having an articulated one is rare. Having three of them together in a burrow is beyond rare. Having the skulls in beautiful condition is beyond rare. And the suggestion of social behavior is remarkable. So Brent wrote this little paper in 1985, and that was the end of it. 1996, as you know, is when Mike Caldwell and Mike Lee got interested in snakes. And it's about 2001 when Brent gives me a call and says, by the way, Mike, we've got this little, what we'd like to think of as a hibernaculum assemblage in our collections here in Laramie. Do you want to work on it? Nobody's ever come down to borrow it, work on it, do anything with it. And I said, well, sure. It took me a few years to find a grad student to put onto the project. And she's the first author on the paper, Chris. That's Jasmine Krogan. And she went at the thing, did up her thesis in record time, proceeded on to her PhD. And that was about 8 years ago. And it took us forever to get the paper arising out of her thesis finished. But that's what this paper represents. So that's sort of the origin story of this particular paper and how it finally made its way into publication. Like a lot of things, it took time, and the people had to evolve in order to catch up to the project. But here we go, and what it reports on, we've got, I think, probably two really cool stories. There's the science side of the story, which is here we've got a 38 million year old trio at different developmental stages of what appear to be close relatives of the living rubber boa, which is widespread across North America. Not my part of North America, definitely way south of where I live, but certainly, into Wyoming, Montana, California, and further south. Secretive, cute, rather polite little boa, totally, for people unfamiliar with anything in the Boinae or Boidae or whatever name you want to apply to the clade. And they think of boas and they think of constrictors and anacondas,
articulated pythons,
snakes on a plane. Yeah, that sort of thing. These guys are absolutely the opposite of that. They're certainly constrictors, but they're burrowing, they're secretive, and we really have never had a fossil record of them other than isolated vertebrae. And here we've got some really spectacularly well-preserved anatomy that gives us some insights on relationships within the rubber boas, within Carinae, and that's the sciencey side. The natural history part of it, which I think is a really fascinating aspect to this story, is the whole social behavior part of it that is suggested by this particular specimen. These three snakes look comfortable with each other. They don't look like they were all killed and rolled across the ground in some sort of storm or flood event and dumped into an animal burrow or a mammal burrow. Rather, they look like they were probably there on purpose. And taphonomically, the White River Formation and the White River Group throughout South Dakota, Wyoming, and wherever you find those deposits, it's all dominated by volcanic ash as a major component of the sedimentology. And the ash was coming from the southern basin and range province in what we think of now as Nevada, New Mexico, which was tectonically active as the Colorado Plateau is going up, and Nevada is forming that whole series of rift valleys that dominates that part of the American Southwest, and it's throwing trillions of tons of ash for millions of years into the western interior basins. So we've got ash falls as part of the sedimentation, no doubt, a bit of a Pompeii kind of effect at times, and thinking of Mount St. Helens and the number of things that died during that explosive event, we would have the same sort of thing happening here. And preservation-wise, these three snakes appear in some sort of social behavior to be either hiding from an ash storm, maybe estivating or bruminating in their little hidey hole, or maybe they were just having a sleep because it was a hot day outside, and they were captured, articulated inside of this ashfall. We don't know. We went with Hibernophis because I'm surrounded by garter snakes who in a few short weeks will start moving towards congregating and aggregating to form hibernacula around here, and I love that part of the season when we'll find 1,000 of these things all rolled up into a ball. A little bit south of me, Chris, there are records of bull snakes and rattlesnakes scooting into a garter snake hibernacula for the winter. So we went with Hibernophis, and that's kind of an ode to that behavior. But regardless, this specimen really does preserve some kind of social behavior in rubber boas, and 38 million year old rubber boas, which I think is absolutely cool. If I had a series of other specimens to compare it to, that would make it even more interesting. But what we do have is one more individual from this same locality, just a short distance away, all by himself, which is sad, in another mammal burrow structure. So the paper reports on 4 snakes in total. Yeah.
Yeah, interesting discovery. I've spent a lot of time with rubber boas, having lived in Idaho, and just an interesting animal. And great. Well, Anything else you want to say about those particular snakes, those specimens, or do you think that kind of sums up that story pretty well?
Yeah, I think it kind of sums up the story. I mean, I'm always really happy when I'm able to help students. If there's a bit of a nice cuddly side to it. I love working with my grad students and helping them bring their work to publication
Mm-hmm.
and to get the stories out that are around these things. It's hard work to figure out how to do it the first time around, and this is Jasmine's master's thesis paper. I think the paper is really spectacular. I brought Mike Lee in on it and his group from Australia. Alessandro Palci was a previous PhD student of mine, and then he went to postdoc with Mike. There's 30 years from Pachyrhachis to the present, Chris,
Mm-hmm.
rolled into that paper
Yeah.
as a result of those collaborations,
Yeah.
and I really like that part of it.
Yeah. So you said 30 years approximately, and so as you're at this point in your career, I mean, obviously science is just a body of knowledge that's growing over time beyond any individual, but as I'm assuming you're towards the back end of your academic career. I mean, what's next in terms of your research programs? Do you have any kind of grand vision or project where you're kind of pulling together, the body of work that you've worked on for those last 30 years? Kind of what's next for you as you head into this stage in your career?
Well, I've still got a lab full of grad students. I've still got 5 in the lab. I've got 2 more PhD students in the pipeline coming my way in the next year and a half. Taylor and Francis, as right or wrong, just commissioned me to do a second edition of my Origins of Snakes book,
Mm-hmm.
and I'm writing one on mosasaurs for Princeton University Press. Fieldwork is still active in Argentina. We're collecting away on new lizard and 3D lizard material from the Cenomanian of Argentina, right alongside of the rear limb bearing Nahash Rio Negrina snake material. I'm not slowing down yet, Chris.
Oh, good.
I'm not quite sure when retirement.
None of us ever
Yeah, I'm
should. I
not
was
sure
just
when
curious
retirement will
how were you reviewing all that
Yeah,
and putting
no,
it
no,
all
no,
together.
no. I
So
know. I'm just reflecting on the question. I'm still seemingly in high gear
yeah, it's good.
and having a great time doing it. I can't lie. I'm still having
Mm-hmm.
fun.
Yeah.
And big picture stuff. The the book writing angle lets you talk about things in a way that you can't
Mm-hmm.
in the peer reviewed literature. And I've come to discover that that's something I'm really fascinated by. I've started a third book manuscript right now, and it's all about time, which I think is, in my experience these last 30 years professionally, or almost 40 if I go back to the early parts of my grad life. Um, Time is that missing element in the way that we talk about evolution in the biological sciences. And it's this thread that I like to pull in from my background in geology and sedimentology and stratigraphy. That's probably sort of the big picture, and then woven into all of this rubbish I've buried myself in the philosophy of science. That's probably the big picture stuff that will start to dominate, the twilight of my career, whenever that twilight starts to come my way.
Yeah. Well, that's great. I'm assuming the Origin of Snakes book, that's also kind of just a big culminating type of project for you. And you said you're doing a second edition of it. Is that
Mm-hmm.
right?
Yeah, second edition is now in the works. Yeah.
Great. That sounds good. Well, we've been going for about an hour now, so I think we'll begin wrapping it up. It's been a great conversation. I've really learned a lot, and I think the audience will take a lot away from this as well. So, but before I let you go, I like to have all of our guests tell me their best snake story. So do you have a good snake story for us? It could be an extant snake, or it could be a fossilized snake. But do you have a good one for us?
Yeah. It's probably going to boil down to one of my fossil snake moments, and I probably gave a bit of a heads up when I was talking about Jerusalem and our museum drawer discovery of Pachyrhachis. In fact, no, let me modify that. I do have a better snake fossil story than that one. After the Pachyrhachis paper was published in Nature in '97, I was invited by the Discovery Channel to do a Paleo World episode called Valley of Venom, Chris. And it was myself and Harry Green. And I don't know if you've interviewed Harry or you know him.
I know Harry very well, and he was our 100th episode not too long ago. So
there you go. Good choice. Harry was one half of the Valley of Venom, and they were following him in literally the Valley of Venom in Vietnam. And then I was the other half. And we were in a number of fossil snake localities, one of which was the Messel Pits, just outside Frankfurt. This is 55 million year old stuff, oil shales, and absolutely beautifully preserved. Pythonine, bowine, Messelophus snakes, like beautiful stuff. And there I was down in the pit, and the film crew is recording me talking about the rocks and the diversity of snakes in the Messel fauna. And the pit is a World Heritage Site, and they've got an active volunteer program. And this older German guy comes past me at that exact moment with a wheelbarrow full of recently excavated chunks of shale. And no word of a lie, it sounds like it's staged. It made its way into the Valley of Venom episode. But as I'm kneeling there and he goes by and he's in full view of the camera, a chunk of shale falls off of the wheelbarrow. It hits the ground. It splits open. I turn to the rock. I look at the camera and I say, wouldn't this be amazing if I pick this up and there is a fossil snake inside this chunk of rock? Lo and bloody behold, as I pick this thing up, right and left counterpart, no head, there is 85% of an articulated fossil snake coiled around on the inside of this slab of rock. It was unbelievable. You'd swear it was staged, but honest to God, it was not. It happened literally in the heartbeat that it happened on film. It was amazing.
Yeah.
That's probably my most incredible fossil snake story, and probably my winner on snakes.
Yeah, that's a great story. I love it. Well, Michael, thank you so much for joining us today on Snake Talk. It's been great. Again, I've learned a lot, and I think the audience will take a lot away from this. So thank you.
My pleasure.
And I just wanted to thank the audience and tell everybody to remember, snakes are animals too, and it's a privilege to see one in the wild.